Today we have Paul Moxon from Denodo, and Paul is going to be discussing the future of data strategy. So I'm sure it will be a very useful session as we look forward to what to expect in the coming years, and I'm sure that it will be full of insights that will help you prepare. Don't forget, you can submit those questions using that Q&A module, and I'll put them to Paul at the end of the session. But I'll let him take it from here, and I'll hand straight over to Paul.
Okay, thank you, James. Welcome, everybody. Let me add my welcome to you. My name is Paul Moxon. I am the Senior Vice President of Data Architectures and Chief Evangelist at Denodo Technologies. And today I'm going to put my head on the line, put my neck on the line, and I'm going to make some rash predictions about the future of how we do data management. This quote is attributed to Niels Bohr. He is a Danish scientist, a physicist from the early part of last century, who did some seminal research into quantum mechanics and built the first accepted atomic model. And he said it's difficult to make predictions, especially about the future. Somewhat sarcastic there, but very, very true. If we look at the analysts who make predictions about the future, people like Gartner, etc., with their hype cycle, we see the hype cycle for data management from just last year. What they do is they look at emerging technologies, they look at the trends in the industry, and then they try to predict the future. They try to predict how these emerging technologies, emerging trends will play out over the next 5 or 10 years. And 10 years in computing is actually a very, very long time, like we know. 10 years ago, we were barely talking about Hadoop and data lakes, and today they're everywhere. So this is a bit of crystal ball gazing by the analysts. And the problem with crystal ball gazing is sometimes there are surprises which come along and change things very, very dramatically. In 2007, the most popular, the best-selling phone around the world was the Motorola Razr, is the flip phone. Some of you may have had these flip phones. I know I did. And in the day when you had the flip phone, they were getting smaller, they were getting lighter. You could do text messages with them, but you had to press the 3 button twice to get the next character and stuff like that. And they weren't very useful, but that was the trend. If you'd have predicted the future of phones in 2007, they'd have been getting even smaller and lighter. And then 29th of June 2007, Apple released the first iPhone, and that has completely changed the way that we use phones. It's no longer a phone for phoning up your friends and talking to them. It's now a computer in your hand. It is your life. In the case of my son, it's his life. His life is on his mobile phone. So Apple completely changed everything, and anybody predicting the future of phones in the beginning of 2007 would have been badly wrong. Similarly, anybody predicting the economy at the beginning of this year would have been badly wrong because of the coronavirus pandemic. So predictions are dangerous. They do have their potential downfalls, etc. So with these warnings, I'm actually going to make 5 predictions, if you like, talk about 5 trends that are going to affect the way that we do data management in the future and the way that it will affect our data strategy. So let's start with the first of those 5 trends. And this is machine learning and AI to simplify the data management challenges. Now, a lot of you as data practitioners, data management practitioners will be aware of these challenges. And lots of organizations are building advanced analytics practices, advanced analytics teams, using machine learning, using AI, etc., advanced analytics to help them, for example, to predict customer behavior. What's their propensity to buy? Are they at risk of churn, etc.? So we're seeing organizations using these techniques already in their data science practices, their data science teams. But you don't have to be a large multinational company to take advantage of some of these techniques, some of these advanced analytics, some of these machine learning techniques. We're going to see many of these techniques actually coming up in the tools that you're using to do your everyday data management. We're going to see tools which will simplify how we manage our data. They're going to discover relationships between data for us. We've already got tools in the area of data governance, for example, which are starting to analyze transaction logs, for example, to try and determine relationships between different data entities from the way people are using it. So instead of the traditional governance tools where you go and read the metadata, and then a data steward who knows about the data, has that knowledge of the data, comes along and defines how the different data entities are related to each other, maybe building a model of the data using modeling tools, etc. Now companies are starting to look at the millions of transactions you have in your transaction logs in your databases and using machine learning techniques to extract the implicit relationships from how people use the data itself. So instead of somebody having to know about the data, we're looking at how people are using it and determining, inferring relationships from that. We already have tools which will go and use machine learning techniques to actually go and identify PII data, for example, and flag it so that you can go and make sure that this particular data is protected, is hidden from improper use, etc. So we're seeing these types of techniques already today in some of these newer products. The governance tool I talked about was a company in Australia called Alex Solutions, who is reading these transaction logs and using machine learning to discover those implicit relationships. And this also applies to data virtualization. Data virtualization is an area that I know very, very well. And data virtualization, because it actually uses federated queries across multiple data sources, it allows you to use these advanced machine learning techniques to discover relationships across different data sources, across your databases for your data warehouse and your MDM system and your CRM system and your data lake. It discovers those relationships there. And it also can use machine learning techniques to make recommendations based on previous usage, people of similar roles. So if you're maybe a data analyst, it will make recommendations of which data sets you should use based on the data that your colleagues in a similar role are using. So we'll see things like this starting to simplify how we manage, how we structure the data, and a lot of the work which required manual intervention, human intervention to do, will now be automated through machine learning and AI. It'll take away the drudgery, the grunt work of this type of activity. So if we move on to my second reckless prediction, but the second trend, and this is all about hybrid and hybrid computing. This data is from a survey that we run annually. This is from our cloud survey of 2020. We ran it at the beginning of this year. We surveyed over 250 global companies, and we have some very, very interesting results. And most companies are actually, the vast majority of companies have actually moved to the cloud. They've got systems in the cloud as well as on-premise, and in many cases, they're actually moving towards multiple clouds. And that's where things get more interesting, because as you move to the cloud, your data becomes more distributed. As you move to multiple clouds, it gets even more distributed again. So that whole environment gets very, very complex, and the big questions about how do I access my data? Where is my data when it's in this multi-cloud hybrid environment? One interesting fact that's hidden in this slide actually is the second from last bullet point. We are aggressively adopting, in many cases, aggressively adopting the cloud, moving data to the cloud, creating new data sources, data lakes, etc. on the cloud. But we're not very good at decommissioning the old systems. Less than 9% of old systems have been decommissioned. Forrester's saying 8%. This means that we're creating new data sources, but we're keeping the old ones. And that trend fits, because if you think about it, we've been predicting that we're going to decommission the mainframes for 50 years, and we're still using them. So I can see that as we move to the cloud, we'll keep our on-premise data sources. We'll never get rid of them, or we'll get rid of very few of them. So we're not necessarily migrating to the cloud as we're extending to the cloud and keeping our own systems. So our environments are going to get more and more complex, more and more distributed, and this hybrid multi-cloud. Now, the danger in many cases is that people think of, oh, I'm moving to the cloud, I'll just connect to my data sources on the cloud. This photograph is actually from Stockholm in 1890. It is the telephone tower, the Stockholm telephone tower, Telefontornet. And when the first telephone systems were set up in most major cities at that time, they didn't have switches and substations and routers and things like that. Everything was connected to a central exchange, and this is the central exchange in Stockholm. It had 5,500 subscriber lines connected to this central tower. And you can see it from the picture. There were wires running everywhere across the skyline, above the rooftops in Stockholm. Obviously, this does not scale very well. The citizens of the residents of Stockholm were complaining back in 1890 that this was unsightly and all the wires darkened the sky, etc. So just imagine trying to do this when you've got data in multiple clouds. You don't want point-to-point connections. You have to look at an architecture that has actually worked very successfully. And this is actually the same architectures we use for the telephone, for the internet, etc. You have hubs or gateways, and they're co-located with your data. And then you connect all these hubs or gateways to each other so that you can access any data from anywhere without having to have a direct connection. Just like on the internet, I can get to any page that I want to on the internet without having to actually have a direct connection to that web server. Or on the telephone, I can phone my mother in the UK, my brother in the United States, my friends in Australia and Singapore without actually having to have a direct connection to their phone. It's all taken care of by the very scalable architecture we've got. And this is the type of architecture that you have to have when you move into this hybrid multi-cloud environment. Stop trying to retrieve and copy everything back to a central location, leave the data where it is, and just make sure people can access it where it sits. If we move on to the third trend, this is voice control and natural language processing. This always makes me think of the what I call the Star Trek computer. It's that perfect computer where Captain Kirk is sat on the bridge of the USS Enterprise. They've just been attacked by the Klingons, and Kirk says, "Computer, give me a status update." And the computer comes back, voice obviously, comes back and gives a perfect description of all the problems, the shield, the starboard engines being damaged, etc. And there's no fog of war, there's no confusion, it's perfect statistics. Now, we all know that voice control is already in our homes. You can use these home automation devices, Siri, Alexa, etc., and you can tell them to switch on the lights. You can even use Alexa to order things from Amazon. So we know these are there already, but they will start to make inroads into BI and analytics, allowing the business users to use natural language, ask questions like you would ask a person, and get the answers back from the system. Obviously, this has still got some way to go, but we're seeing some of this already. Logitech, a Swiss company, it's a multinational company, but headquartered in Switzerland, they are actually using this already. This allows their business users to use a chatbot. It's not voice control, but it's natural language processing. They can use a chatbot and they can type in a question, a natural language question, the way they would ask it to a person. The chatbot is connected to an NLP tool. The NLP algorithms will go and interpret their typed question, and then it will actually do a query on the back-end system to get them the results and send it back to them as a natural language expression. Now, you can imagine this is using a chatbot today, but if you extend that a step further, then you can actually go out and start saying, well, instead of a chatbot, maybe I have something like an Alexa in front of that chatbot. And actually, one of our engineers at Denodo has actually built a system, a demo system, where you can ask Alexa a question in the back end. It will go and do a query against the data, get the results back, and send them back to you. So voice computing, natural language processing, to take away the technical nature of data and analytics is something that we will see more, making it easier for the business users to ask the questions they want without having to know how to type a SQL query or something like that. So the fourth trend, data monetization and the API economy. We are seeing that companies nowadays are treating data as an asset. Data as an asset with strategic value, instead of just something which fuels reports and stuff. It's got real value. And you know, companies like Google and Facebook, they collect a lot of data about you, about me, through using the browser, through Facebook, and all sorts of data collection techniques that they have. Google use on your mobile phone. If you're using Google Maps or Apple Maps, they can trace where you go, etc. They don't sell this data as such. They sell information that is extracted from that data. So, for example, if Google is tracking me and they know that I go to a certain store on a frequent basis because I use Google Maps and I have tracking on, then they can sell that knowledge that I go to a certain store to other retailers, for example. Even close to home, if you think about the supermarkets that you shop in, they're tracking what you're doing in the store, what products you're buying, etc. And they sell that knowledge to their partners. It could be suppliers who actually sell products so that they can make you special offers on the basis that you used to buy their product, but you haven't bought it for the last few months, etc. So data has a real value, and people are starting to understand that now. And we have companies out there which are, we have combinations of data aggregators and data brokers, I'll call them. Data aggregators are just people who collate data from all these different websites, different sources, etc. Data brokers are companies like Drilling Info in the oil and gas industry. Drilling Info gather data from public filings. In the United States, if you drill an oil well, say you've got an oil well in Texas, you have to provide regulatory information about that oil well, about the production coming from that oil well, how many barrels of oil you extracted, etc. You have to provide this on a monthly basis to the authorities in the state of Texas and the U.S. federal authorities, the Department of Energy. Drilling Info actually collect all of this regulatory information, these regulatory filings, and then they go and aggregate it all together. They apply some analytics to it, some of their own secret sauce, and they then go and sell it sometimes back to the people who filed it in the first place. So they're collecting it, and then they're allowing the people who did the filing to go and look at their data, pay to get to the data from Drilling Info. So if I've got an oil well in the Permian Basin in Texas, I can look at how much production I get from my oil well and then compare it to the ones of my competitors or neighbors who have got oil wells nearby to me. So I can see if my oil well is being very productive, underproductive, average, etc. So that's the type of data monetization that we're seeing out there. Some aggregating it, some enriching it, adding extra value to it. So you're not just paying to access the data, you're paying to access the data with some added value into it. And I use Drilling Info as an example because Drilling Info actually uses a data virtualization platform to actually build their data services, their APIs, to drive that API economy side of it, where people can subscribe to their data services, their APIs, to access the information they need, and have that metered so that from a company basis, from Drilling Info's basis, they can actually meter and manage how people are accessing the data, how much data they're accessing, what data they're accessing, etc. So the fifth and final trend that we have is data fabrics and adaptive data architectures. Now, you will hear the analysts, Forrester and Gartner, talking about data fabrics. And again, this goes back to that Stockholm telephone tower example I gave, that instead of trying to connect to all of your different data sources on the cloud, on premise, some of them, it may be tools like Salesforce, so SaaS applications, etc. Instead of trying to connect directly to all of these different tools, build that architecture, that multi-location, multi-cloud architecture I talked about. And if you weave it together, and this is where the word data fabric comes from, you weave all of this fabric together, all of these data points, all of these data hubs and gateways, etc., and you end up with a fabric which layers on top of your physical data repositories, physical data sources. So that's when we talk about fabric. And obviously from a data management perspective, you have governance, you have security, you have data preparation, data curation of capabilities built into your data fabric. But the analysts will be talking about a data fabric and the need for companies to build a data fabric. I also argue, and I also say that this is essential, that you have to make an adaptive data fabric, and I'll explain adaptive in a few minutes. So Gartner have also talked about the evolution of data architectures, especially in the analytical environment, talking about building up to providing logical data architectures, moving away from physically trying to copy the data into a central location, to putting this logical semantic layer over the top of your data sources so that people can connect to this data access layer, to this semantic logical layer, and not have to worry about all of the complexities of that data architecture. Very, very similar to what Forrester were talking about with data fabric. Gartner are also talking about data fabric. They're talking about it as being the next generation of their logical architecture is really their data fabric. So they're talking about the same things, really. Now, my argument and my trend, my prediction, if you like, is that these architectures also need to be adaptive. We don't know really, in all honesty, we don't know what technologies is going to come along and go mainstream and affect your data architectures, your data management practices in the next 3 to 5 years, or even 5 to 10 years. Gartner's hype cycle is making a prediction, but we don't know how accurate that's going to be. And my example of this is that 5 years ago, hardly anybody was talking about Parquet files. 10 years ago, nobody was talking about Parquet files. And yet everybody now seems to be storing data in Parquet files in their data lake. So we have to think about, okay, new technologies, new data sources, new data formats are going to come along. How can we build architectures which will easily allow us to adopt these new technologies, new formats, new data sources, without causing wholesale disruption to the users? Also allow the users to introduce new tools that they want to do. They're using Cognos or business objects today. They want to use Power BI tomorrow. We don't know what they're going to use in 5 years' time. But at the same time, we also need to think that, well, people will still be using Excel spreadsheets in 5 years' time. So we have to build something which will support today's technologies and tomorrow's technologies. And that's what I call an adaptive data architecture. And we've got an illustration of that where we have our data sources and we have our data consumers. Now, typically in our analytical environments, we go and build data lakes and data warehouses in there. That's where we consolidate the data. We move it into there using various techniques such as ETL, streaming data, etc. This is today's typical data architecture. The adaptive data architecture, the data fabric style data architecture, if you like, has this data access layer, this semantic layer, where you define how the users should see the data instead of how they physically access it. This is that logical layer that Gartner talked about. It's the data fabric that Forrester talked about. To make it easier for users to find and access the data, that data is coming from directly from the data system, data sources. It's coming from the data lake. It's coming from the data warehouse, etc. And the users don't go directly to those data sources. They go through this data fabric logical data layer. That's what I call the adaptive data architecture. That's the data fabric. That's the data fabric part of it. This is adaptive because if I get a new technology coming in, then I can very easily plug it into the left-hand side, and the users on the right-hand side can access it without having to know about where's it stored, what's the driver or protocol I use to access it. So this type of thing makes it very easy for you to adapt and adopt new technologies, new data sources, new formats, etc. And also for the users to come and pick and choose their own tool to use and still access the data without going to IT and saying, please, can you help me? I've just got this new tool and now I need to connect to so-and-so. No, you just plug into this data fabric and I can get the data I need. And with that, I'm going to hand things back to James so that we can do any Q&A. James.
Absolutely. Thank you for that, Paul. I thought it was a really interesting presentation and always a brave man who's willing to make several predictions for the future. And so thank you for that. As Paul said, we have got some time for questions, so we will go through as many as we can in the time. If you want to ask a question to Paul, just type it into that question box, hit submit, it'll come through to us and we'll cover those. I'll kick things off with a question of my own. So I thought that it was a very interesting concept, the idea of the data fabric and using that kind of approach to data architecture. Do you see that kind of concept of a data fabric being something that you can, have out of the box product suite that you can get out of the box from one vendor, or do you see that more being kind of a mesh of different solutions?
Yeah, I think it's definitely going to be that mesh of different solutions, as you put it, a best of breed. I'm sure that some vendors, some companies, some software vendors will say you can buy it from them. And then they'll sell you an army of consultants to go with it, so you can put it all together for you. But most companies are going to buy best-of-breed products and sort of fit them together. And if they're picking the best-of-breed products that use good standards, they will fit together fairly easily. I think that things like a data fabric, logical architecture, it's not a product you buy, it's an architecture. It's a conceptual architecture as opposed to an off-the-shelf product that you buy. So always be suspicious if somebody's trying to sell you a data fabric.
Absolutely. Thanks for that, Paul. We've had a question for you which links in quite well with that, actually, which is what's the difference between a logical data warehouse and a data fabric?
Okay, some of this can come down to just the wording, the semantics of it. I view it that a logical data warehouse is something that it's terminology that Gartner used, probably came up with it, I think it was 2012. So it's 8 years old already. I think data fabric is a recognition that we've gone into this hybrid multi-cloud environment. So the concept of a logical data warehouse could still be in a single location. This is taking it and saying, okay, this is going to run on different clouds. It can involve SaaS applications as well as running on AWS and Azure, etc. So it's this expansion of a logical data warehouse into this hybrid multi-cloud environment.
Yeah, that makes sense. And as you say, I suppose it's an evolution maybe of that idea.
Yes.
Yeah, that makes a lot of sense. Thank you. So we've had another one here, which is can SAP be included in a data fabric architecture with DV?
Sorry, could you repeat that, James?
Yeah, can SAP be included in a data fabric architecture with DV? I guess it's a question around. Yeah, go on. Sorry.
Yeah, I'm assuming it's around SAP, and it could be their ERP suite of products. In which case, yes, I mean, SAP have many different products, and depending on which ones you look at, they certainly can be part of a data fabric. The idea is that a data fabric can include any technology, any product. So if we're talking about SAP S4, their ERP suite, yes, you can include that. If you're talking about their data warehouse, SAP BW, you can include that. If you're talking about business objects, we can include that as well as a consuming tool from the data fabric. So yes.
Yes, hopefully that answers the question. So thank you for that. What is the use of, or I suppose how can you use, what is the use of artificial intelligence and machine learning around data management? And I know this is a topic that we see quite a bit, that people are interested in how they can use AI and machine learning and apply that to data management. Do you have kind of any thoughts around that?
Well, yeah, this is one of the trends that I talked about. In many cases, in the area of data management, we still rely too much on the knowledge in people's heads. If you go and look at a data warehouse, let's say it's a data warehouse that you've had for the last 10, 15 years, there's a lot of knowledge in that data warehouse which isn't written down anywhere. Now, then, usually you have to go to, go and talk to John. He's the expert. And you go and ask John, how do these data entities relate to each other and things like that. And John's the one who designed it, so he knows what this means and things like that. If John ever leaves, you're in trouble. We're using machine learning and AI now to actually go and look at how people are querying that data, how they're using that data, and inferring relationships, inferring knowledge from how people are using it and querying it. And that's looking at transaction logs, which have got hundreds of thousands or millions of records in them. You can't do that manually. So instead of saying, go and talk to John, we've got advanced analytics, machine learning, which is actually starting to trawl through these logs and work out how these data entities are all related to each other based on their usage of the data, which is probably more important than what John thought about when he built it 10 years ago. It's how people are using it today. And you can only do that with machine learning, trying to infer these relationships. So we're starting to use machine learning to do this, and we will continue using it to extract the knowledge out of existing systems, and also to help us remove some of the drudgery of what I call the data steward role, who has to go around and flag PII data. Well, we can infer that automatically. You can look at a database, you can look at all the values and say, oh, this is a national insurance number. It looks like a national insurance number. Let's flag it as PII data so we know how to protect it, instead of somebody having to go and look at all the data to work this out. So that's one of the biggest areas where we'll see machine learning within data management, just removing that reliance on human knowledge from 10 years ago in John's case, so that we can speed it up, we can automate it, we can capture that information.
Yeah, and presumably free up some of John's time as well, which I'm sure is another benefit for John. So the next one we had here is, so this is an interesting one. This is around connecting legacy systems and new data systems. So the question is, what about the performance when a logical data factory connects the legacy and the new data systems?
Performance is always an issue when you're trying to combine data like that. There are some things that the data fabric, the data virtualization layer can do to improve performance. There's some advanced optimization techniques. You can do caching to keep local copies of the data instead of going back to that legacy system time after time. So what my experience is, what I've seen is that these techniques are improving over time. I mean, that some of them are very advanced today. There are lots of techniques we can use. But over time, and again, going back to your previous question about machine learning, using machine learning and looking at past performance and using that to understand how to better optimize for future performance, you'll see techniques like that as well.
Absolutely. So here's another one. So when you avoid point-to-point connections, doesn't that compromise the concept of a centralized enterprise data warehouse / data fabric? So I suppose the idea when you're talking about avoiding those, but you're not needing those point-to-point connections, doesn't that kind of contradict maybe or undermine the idea of having this data fabric?
It doesn't undermine it. As a matter of fact, I think the only way you can have a data fabric is to avoid point-to-point connections. Again, I use the analogy of the internet of the phone system, that if we were still running point-to-point connections like in Stockholm, it limits how much scalability you have. Think about how many billions of phones there are in the world today, and you can phone any one of them. You can't scale that with point-to-point connections. It's like everybody walking around with a tin can and a piece of string for every friend that they know, so that they can talk to them like you used to do when you were a kid.
Yeah, absolutely. Makes sense. And I think we've got time for one final question, which is a very timely one. It's coming back to maybe some of the predictions that you were making at the earlier part of the presentation. And the question is, do you have any predictions for how COVID will impact the use of this technology?
Actually, I've got examples of how adaptive data architectures, flexible data architectures, have allowed some companies to respond in the COVID pandemic in ways they couldn't do using traditional technologies. One example is actually from the UK. It's a high street retailer. And obviously, when the pandemic hit and everything was locked down, they had to close all their stores. But at the same time, they found that the demand for their food products shot through the roof. And they had to actually suddenly change their business model so that they weren't selling clothes and home goods and things like that, shoes, etc. They had to focus on selling food products. So they had to contact their suppliers to increase the orders, demand for food products. They had to change their logistics operations so that they could do the home deliveries. They had to do this in 2 or 3 days. They couldn't wait for 3 months for somebody to ETL and load the data into the data warehouse so they could change their logistics home delivery schedules. A competitor would have taken their food away. So they had to do this in a matter of days. So we saw the pandemic has made companies realize that they have to be more agile, they have to be more adaptive, they have to be more flexible in the way that they manage their data. to make these pivots to their business model in a matter of literally days and weeks instead of months like it would normally take.
Absolutely, and about having the technology to enable that pivot to happen, I suppose.
Yes, absolutely. You have to have the architecture, you have to have the technology, and you have to be, as an organization, you have to be flexible enough to say, we're going to change. We don't want to have a steering committee to discuss this for 5 months to agree that we need to change. We need to change, just go and do it. Is that more of a flexible mindset with the technology, with the architecture, all worked. And this high street retailer, its bright spot was actually its food sales. Its clothing sales stopped, 0, but its food sales increased by over 100%. And now it's actually using some of the data that it collected through its food sales to work out which store should open first, which are the most profitable ones, and which ones should open first now that the lockdown's being relaxed, etc.
Yeah, that's very interesting and very timely topic to discuss as well. But unfortunately, we are out of time. But a big thank you to you, Paul, for joining us and sharing your experience and for tackling those questions at the end and making your predictions. So thank you.
Thank you. Thank you, everybody.